Jai Hind everyone, and this is Navjyoti Sharma giving you the lecture on mesh analysis and node analysis, which is one of the topic in unit 1 of the subject Fundamentals of Electrical Engineering. The first unit of it is DC circuits. So, we are going to see how can we analyze DC circuits with the help of mesh analysis and node analysis. So, coming to mesh analysis, right? So, this is the analysis which is based on KVL, right? KVL is Kirchhoff's voltage law. Kirchhoff's voltage law. In a closed loop, the algebraic sum of all the voltages is equals to 0. That is the shortest form what we can give, right? Or I may be saying that in a closed mesh or in a closed loop, the sum of all voltage rise is equals to sum of all voltage drops, right? If we follow this law, we can be going easily with the mesh analysis, right? It is based on KVL only. So, when I say how to proceed on with the mesh analysis, right? How to go for the equations of mesh analysis. So, let us consider if at all I am having a DC circuit having a voltage source V1, say resistance right. This is some R1, this is some R2 and this is some R3. Fine. If in this circuit, right, the question being asked is, and this is R4, find the current flowing in R4 using mesh analysis. If the question is, what will be the current in R4 using mesh analysis? Okay. How to proceed on with this? We have to apply KVL, right, in a closed loop. So, first of all, the very first step, if at all I say, the step 1 would be identify the number of meshes in a particular circuit, right? Identify the number of meshes. So, if at all I see how many meshes are there in this particular circuit. So, how many meshes are there? Meshes means the smallest closed circuit what can be formed in a network, right? So, if at all I see this, the smallest closed circuit that can be formed in this network, that will be 2, right? That will be 2 other meshes, okay. The second step, so I have identified the number of meshes, that is 2. Fine. Step 2, assign mesh currents to them, right? To these meshes. What we have to do? In these meshes, I have to assign mesh currents. Fine. So, I have found out that I am having 2 meshes. One is the closed path, this. So, this is mesh 1. I am assigning the current as I1, clockwise is the direction. Another one is the closed mesh, this. I am assigning it the current as I2. If that is so, now I have identified the number of meshes, I have assigned the mesh current. What can be the third step? Now, apply KVL to individual meshes one by one, right? Apply KVL to individual meshes and form simultaneous equations. Right? If that is so, mesh number 1, applying KVL to mesh number 1. If at all I see, if at all I apply KVL to mesh number 1, what will be the equation going to be? In mesh number 1, I will start with the voltage source, right? Let us see the drops and the voltage drops which are occurring. Right. Now, for this voltage, the polarity is negative, positive, but the current is flowing in the resistor this way. That means the polarity of the voltage across R1, that is going to be plus minus. The voltage is going to be I1 into R1. Similarly, the voltage across R2 is going to be the current through R2 multiplied by the resistance R2. What is the current through R2? It has to be the difference of I1 and I2. Why? Because I1 is flowing downward and I2 is flowing upward. So it is very much evident, it is very much clear that whatever is going to be the current in R2 has to be the difference of I1 and I2. Which one is the greater, right? If that is so, let's write the KVL equation for mesh 1. For mesh 1, applying KVL, it is going to result, I am starting from here, negative, positive. Whenever I am moving from negative to positive, I am considering it to be a voltage rise. That means it is positive. If that is so, I will be considering it as V1. Okay. Then, if this is V1, further, positive, negative, it is acting as a drop. Drop, what is the drop occurring over here? I1 into R1. I1 is the current, R1 is the resistance. So, I will say minus I1 R1. Next, the next element which is occurring is R2, right? So, in this, if at all you see, I1 is downward, I2 is upward, the difference of the two. Presently, I am writing the equation for mesh 1. So, I may consider, I do not know which one is greater. So, I may consider that I1 is greater than I2, right? I may be proved wrong later on, fine. But presently, I am considering that I1 is greater than I2. If that is so, that's why the drop across R2 would be positive and negative, isn't it? So, if this is a drop, it has to be positive, negative, and we are considering I1 is greater to I2. That's why I'll be writing it as I1 minus I2 multiplied by R2 is equals to 0. No more element left. So, my KVL equation for this becomes V1 minus I1 R1 minus I1 minus I2 into R2 is equals to 0. I may resolve the same in terms of I1 and I2, right? So, I may be writing it as minus I1 R1 minus I1 R2 plus I2 R2 is equals to minus of V1, right? I may write here minus I1 R1 plus R2 plus I2 R2 is equals to V1. This is minus V1. This is equation number 1. This is first simultaneous equation, what can be attained, fine. If that is so, now I may be moving on with the next, applying KVL to mesh 2. In this mesh 2, if at all I see, what can be the expression for this? This is R2, R3 and R4. The current flowing is I2. If in this case I apply KVL, applying KVL to mesh 2, applying KVL to mesh 2, I will be getting, right, now R2, this time I am considering because the drop will be according to I2, right. So, the drops will be positive, negative, positive, negative, positive, negative. So, the equations are going to be the current in R3, that is I2 R3. Once again, the current in R4, it is going to be plus I2 R4 plus the current once again in R2 is going to be I2 minus I1 multiplied by resistance R2 is equals to 0. Once again, the same equation can be resolved in I1 and I2. I may resolve it into I1 and I2 as minus I1 R2 plus I2 R3 plus R4 minus plus R2 is equals to 0. Fine. So, this is my equation number 2. So, I have resolved the earlier equation and the present equation in I1 and I2 form. I may be applying Cramer's rule, or I may be solving 2 or 3 simultaneous equations without applying some Cramer's rules also, and identify the value for I1 and I2. Now, once I got the value for I1 and I2, I may be finding the voltage across each element, the current through each element and the power drop across each element, right. So, every quantity can be found out once I am done with the currents in the 2 meshes. That is how we used to go for mesh analysis. Let us go for certain university numericals which has occurred in the university exams of AKTU, right. So, let us go for the numericals of those based on loop analysis or mesh analysis. Find the current in 2 ohm resistance for the following figure using loop analysis method. Fine. So, the circuit is shown over here. Now, with this, if at all I continue, right, once again, our first step, identify the number of meshes. What I want to know the current flowing in 2 ohms, in this ohms. Fine. For this, I need to first identify the number of meshes. How many number of meshes? Once again, 2. Fine. Second step, the second step was assign mesh currents. So, I have identified the number of meshes and I have assigned the mesh current. The first current is I1, the another current is I2. Fine. Both are clockwise. If that is entirely our wish, whether we want to keep it clockwise, anti-clockwise, one clockwise, whatever, right? Later on, depending upon the current directions, we'll be getting the exact answer. Fine. If that is so, applying. Now, the third step was applying KVL to mesh 1. When you apply KVL to mesh 1, what will be the equation? I'll start from here. It is negative, positive, 40. Then positive, negative, positive, negative. It itself is positive, negative, right? So, I'll write all the rise towards one side and all the drop towards the another side. So, 40 is equals to 4. What is the current flowing in? 4, I1, okay. Plus 2. What is the current flowing in 2? That is I1 minus I2, considering that I1 is greater than I2, right? One more left, that is 20. Positive, negative. It is a voltage source, but presently it is acting as a drop. So, I'll mention it as plus 20 towards the drop side, right? And now, I will resolve it in I1 and I2. So, the equation I'll be getting is 40 minus 20, that is 20 is equals to 4 plus 2, that is 6 I1 minus 2 I2. That is equation number 1. Now, one is got, then applying KVL to mesh 2, once again, applying it to mesh 2. Now, this time I will consider I2 is greater than I1, right. In this case, if at all I see, once again, I am starting from here, negative, positive, positive, negative, positive, negative, once again positive, negative. So, the equation now goes, this is 20 is equals to, this is negative, positive, positive, negative, 2, and this time the current is I2 minus I1 plus 3 I2. Plus 10, 10 towards this side. So, the second equation what I will be getting is 10 is equals to minus 2 I1 plus 6 I2. That is my second equation. I have got the two simultaneous equations. Solving these two equations, 1 and 2, I will be getting I1 is equals to 4.615 and I2 as 3.826, right. So, I1 is 4.615 and I2 is 3.826, 4.615 and I2 is 3.826 with positive currents. That means, I need not to change the directions what I just consider are perfectly okay. If that is so, the question was not this, the question was I need to know the current in 2 ohms. So, the current in 2 ohms is going to be the greater current minus the smaller current. The greater current is I1, I1 minus I2. So, that is 0.764 amperes. So, that is the answer for this numerical. Similarly, the another one, write the Kirchhoff's voltage equation for the circuit shown and hence find the current flowing through the 4 ohms resistance. If that is so, once again, right, identify what I need to know. I need to know the current in 4 ohms, right. In this particular case, the meshes are also assigned, the mesh currents are also assigned, right, fine. So, we need not to do this exercise. 3 are the meshes, right, and the 3 are the currents with all the 3 giving clockwise direction, fine. I need to know the current flowing in 4 ohms. If at all orally I see what is the current flowing in 4 ohms, that is I1. So, I only need to find what is I1, fine. But for that, I have to apply mesh analysis. For mesh analysis, once again, 2 steps are done. Third step, I need to apply KVL to individual meshes. Fine. Now, once again, writing the KVL equation for mesh 1. For mesh 1, if at all I write, once again, we are used to it. I am starting with this negative, positive, positive, negative, positive, negative, and positive, negative, right? If that is so, I'll start with 24. 24 is equals to 1. And what is the current flowing in 1 ohm? Is it only I1? No. This is the common element between two meshes. So it has to be either the addition or the subtraction of the two current, right? So let's see, I1 is flowing in clockwise direction, right? I2 is also flowing in clockwise, but in 1 ohms, one is moving towards right and the another one is moving towards left. That means in 1 ohms, it has to be the difference of the two. I am considering I1 to be greater, so it is 1 into I1 minus I2. Similarly, the other one, 3. Once again, plus 3. What is the current in 3? Once again, I1 is greater, I1 minus I3. Plus 4. What is the current in 4? It is only I1. So, it is 4 I1. Resolving this in I1, I2 and I3, the equation would be 8 I1 minus I2 minus 3 I3 is equals to 24. That is equation number 1. Now, applying KVL to mesh 2. When you apply KVL to mesh 2, what is going to be the equation? Now, this is my mesh 2, right? I am starting from here, negative, positive, positive, negative, positive, negative, positive, negative. If that is so, applying KVL to mesh 2, I am starting with 12. So, it has to be 12 is equals to 2, the current flowing in 2, that is only I2. Then plus 12, the current flowing in 12, I2 difference I3. Once again, 1, what is the current flowing in 1? It has to be I2 difference I1. Resolving these, I'll be having the equation I1, I2 and I3. I'll be having it as minus I1 plus 15 I2 minus 12 I3 is equals to 12. That is equation number 2. What is left? Mesh 3. Once again, applying KVL to mesh 3. What will be the equation? Mesh 3. This is positive, negative, positive, negative. That itself is positive, negative, positive, negative. All of these are drops, right? So, I can be taking it on the one side. Fine. So, I am starting with 12. So, this time I may be writing it as 12. What is the current flowing in 12? I3 minus I2 plus 2. What is the current in it? Only I3, right? Then 10 volts. Although it is a battery, but it is working as a drop. So, plus 10 plus 3. The current is I3 minus I1 is equals to no rise. So, once again, when I resolve it in I1, I2 and I3, I will be having the equation as 3 I1 minus plus 12 I2 minus 17 I3 is equals to 10. Solving the 3 equations, if at all I do 1, 2 and 3, I1 is going to be 4.111 ampere. What is this current? This is the current what I want. That is the current which is flowing in 4 ohms. Fine. So, this is the third question which has occurred in university, that is use Kirchhoff's laws to find the current supplied by the battery for the circuit shown using Kirchhoff's laws, right? KVL. We are going to use KVL over here, right? Once again, in this circuit, once again, how many meshes are there? Using the very first step, identify the number of meshes, 3 meshes. Assign mesh currents. I have assigned the mesh currents, I1 clockwise, I2 clockwise, I3 clockwise. Once again, same. Applying KVL to mesh 1. What will be the KVL for mesh 1? Here, if you just see, I am having a battery, if at all you see, I am having a battery with 4 ohms internal resistance, right? So, I need to have this 4 ohms internal resistance being connected over here. Fine. If that is so, now we can write the equation for mesh 1. This is negative, positive, positive, negative, positive, negative. This is my mesh 1, isn't it? I need to cover these elements. If that is so, applying KVL to mesh 1, the equation would be negative, positive. That means 100 is equals to 12 I1 minus I2 plus 3 I1 minus I3. One more left, that is 4 plus 4, but the current in 4 ohms is only I1, right? Resolving it, I may be getting the equation as 19 I1 minus 12 I2 minus 3 I3 is equals to 100. Fine. This is for mesh 1. Once again, applying KVL to mesh 2. in this mesh. How many elements? This, and this. Once again, positive, negative, positive, negative, positive, negative. All are these are drops. Writing the KVL equations, I am starting with 3. So it is 3. The current in 3 ohms is only I2. Am I correct? Then plus 50. The current in 50 ohms, it is in between 2 meshes. I2 minus I3 because the directions are opposite. One is moving downward, another is moving upward. Last one, that is 12. The current in 12 has to be I2 difference I1. Once again, I2 is moving towards left, I1 is moving towards right, is equals to no rise, 0. Resolving it, I will be having the equations 12 I1 minus 65 I2 plus 50 I3 is equals to 0. Third mesh is remaining, applying KVL to mesh 2 because I am having 3 unknowns, I need to have 3 equations, I need to apply KVL to all the 3, right. So, for mesh 3, if at all I apply KVL, in this I will be having third mesh. This is mesh 3. For mesh 3, if at all I apply, once again I am having 1, 2 and 3 components, right. According to I3, I will be providing the drops plus minus and plus minus, right. If that is so, once again 50, all these are drops, current is now I3 is greater, do remember. So, I am writing I3 because drops what I have assigned is according to I3, right, according to the direction of I3. So, I have to keep I3 to be greater. So, I will be keeping it as I3 minus I2 plus 7. What is the current in 7 ohms? The current in 7 ohms is only I3. Then plus 3. What is the current in 3? I3 minus I1 is equals to 0. Resolving it, I will be having the third equation, that is minus 3 I1 minus 50 I2 plus 60 I3 is equals to 0. Solving the 3 equations 1, 2 and 3, I will be getting I1 as 10.1634 amperes. The question being asked is what will be the current through the battery, or what will be the, what is the current through the battery. So, the current through the battery, that means 100 volts battery, that has to be 10.1634, right. Now, coming to the another analysis method, that is node analysis, right. How we would go for node analysis. Now, as we have seen, mesh analysis, that is based on KVL, Kirchhoff's voltage law. Node analysis, as it is signifying, this is based on KCL, Kirchhoff's current law. What does it states? It states that in a network, at a particular junction, the sum of all current leading towards the junction must be equals to the sum of current which are leaving the junction, right. That means the sum of all incoming current is equals to sum of all outgoing current, right, at a particular junction in a electrical network. If that is so, right, how can we apply node analysis to find the unknown currents, thereby unknown voltages, thereby unknown power? Fine. If that is so, let us go for an example, right, as we have gone for the example in case of mesh. Say, this is a voltage source, a resistance, one more resistance, one more resistance, one more resistance. Say, this is some V1, R1, R2, R3, R4, R5, and this is some V2, right. Say, the question can be, find the current in say R2, get me the current in R2 using node analysis, right. How do we go for it? So, as we have gone in case of mesh analysis, we will do the same process, right. As in case of mesh, how we have started? Identify the number of meshes. Here, I will identify the number of junctions, right. So, for this particular network, I will identify the number of junctions. Junction, it is the node, or it is that point in the network where 3 or more than 3 branches meet, fine. If that is so, in this network, how many branches, how many the junctions are there? If all I see, I am having 3 junctions, right. Junction number 1, junction number 2, and junction number 3. Fine. So first point is over. Identify the number of junctions. Second, assign junction voltages. Assign junction voltages. If I need to identify the junction voltages, so V1, V2 and V3 would be the junction voltages, right? V1, V2 and V3 are the junction voltages. Fine. 2 steps are over. Third, apply KCL at different junctions and write the equations. Prior to that, right, out of these 3, I need to have one of the junctions being assigned as datum junction or reference junction, which is having the voltage as 0. I may keep any one as my datum junction or reference junction with the potential of 0, but it is always convenient the one which is coinciding at the lower bottom side to have it as, because the current is assumed to be flowing from higher potential to lower potential, right. So this 0 potential gives us the implication that all the currents would be getting towards this 0 potential, right. Otherwise, I may be keeping V1 as 0 or V2 as 0, as any junction can be considered as datum. Fine. So V3, the junction is already known. So now I am having only 2 junctions for which I need to write the KCL equations, right? KCL equations. Fine. Going for the first one. How to write the KCL equation at junction 1? Apply KCL at junction 1. When I apply KCL at junction 1, I need to see how many junctions, how many branches are there. I am having 3 branches, 1, 2, 3. Say this is I1, this is I2 and this is I3. So I may be writing, if at all I apply KCL at this, the sum of all incoming current is equal to sum of all outgoing current, right? If at all I consider that this V1 is at highest potential, right? If this is at highest potential, that means all the currents will be leaving the junction, right? So 3 branches, all the currents would be leaving the junction. I1 is also leaving, I2 is also leaving, I3 is also leaving. That is completely depending upon our perception. Fine. If that is so, the equation will become I1 plus I2 plus I3 is equals to 0. Fine. If that is so, how can I write I1 in terms of voltage and resistance? Right. Here the potential is V1. Say let this be A, not 1, and this be VB. Otherwise, we will have a confusion, right? So I'll write V1 minus VA upon R1, right? So I1 is given by V1 minus VA upon R1 plus I2. What is the potential here? V1. What is the potential here? 0. That means V1. What is the resistance? V1 upon resistance is only R2 plus I3. What is the potential here? V1. What is the potential here? V2. So that becomes V1 minus V2 upon what's the resistance? R3 is equals to 0. I may resolve it in V1 and V2. That will give me equation number 1. Right? Similarly, if at all I apply KCL at junction 2. Once again at junction 2, how many branches? 3. Let's name them. Once again, I4, I5, I6. This time what I am doing, I am consider that V2 is at highest potential, so that the currents which are at the junction 2 are all leaving the junction, right? So I4, I5, I6 all are leaving the junction. If that is so, now once again, if at all I apply KCL at junction 2, if at all I apply my KCL, once again, I4 plus I5 plus I6 is equals to 0. Right? If that is so, how can I write I4? Once again, I4 is V2 minus V1 upon R3. V2 minus V1 upon R3. I5, it is V2. What is the potential here? 0. So V2 minus 0 upon R4. What about I6? I6 is V2 minus VB upon R5. Is equals to 0. What is the case if this potential over here is reversed? If the polarity of this voltage source is reversed? In that case, if you just see, now we are considering the current to be downward, but this battery is sending the current in upward direction, supposed to be, right? So that's why we are taking the difference. If the potential is reversed in this case, I would have done V2 plus VB upon the resistance R5, which is not in the case. So once again, resolving it in V1 and V2, I'll be having equation number 2, right? Equation number 2, resolving, I'm having now 2 equations, 2 unknowns, will be solving the equation for one V1 and V2. Once V1 and V2 we got, I may have any current. I may have I1, I may have I2, I may have I3, I may have voltages across each element, I may have the power loss across each of the element. Okay, just going for certain numericals like using nodal analysis, find the current in 1 ohms for the network shown, right? In this case, now once again, identify the number of junctions. If at all I identify the number of junctions, I am having 3 junctions, right? Here, here and here. If at all I see here, this is V1, assigning the voltage. Here, assigning the voltage V2. Here, V3. Out of that, I have considered VD through B at 0 potential. Fine. Now, I need to write the KCL equation at the 2 junctions. Applying KCL at node 1. At node 1 here, if at all I apply, what will be the equation? Once again, this current plus this current. All the 3 currents addition is going to be 0, right? The equation would be written as V1 minus 2 upon 2 plus V1 upon 3 plus V1 minus V2 upon 1 is equals to 0. Resolving it, I will be having the equation as 11V1 minus 6V2 is equals to 6. Similarly, when I apply KCL at junction 2, what will be the equation? V2 minus V1 upon 1 plus V2 upon 5. But here, this itself is a current source. It is giving the current in upward direction. Other 2 are outgoing, but this is upward. So I need to connect it as minus 0.5. That itself is a current. I need not to write it in voltage and resistance term. Once again, resolving it in V1 and V2, I will be having minus 5V1 plus 6V2 is equals to 10. Solving the 2 equations 1 and 2. This is equation 1 and equation 2. I will be having V1 is equals to 2.66 volts and V2 is equals to 3.88 volts. V1 is 2.66, V2 is 3.88. What is the question? The question was, I need to know the current in 1 ohms. The current in 1 ohms. So it has to be the difference of V1 and V2 upon 1. Which one is greater? That is V2. So the current through 1 ohm has to be 3.88 minus V2 minus V1, 2.66 upon 1. So it is going to be 1.22 amperes. In which direction? From 2 to 1, towards left, or I may say towards right of mine. Similarly, the another question is using nodal analysis, find the current through 8 ohms. Once again, going with the very first step, identify the number of junctions. How many junctions? 2. Assigning the junction voltages A, B, considering that the third one VC is 0 here, right? That I will reference. Then, if that is so, once again, applying KCL at junction A, what should be the expression if at all I apply? Now here you just see this is 10 volts, negative, positive, positive, negative. That itself is cancelling out. In fact, if at all I write, I will be writing it as VA plus 10. This is sending the current in the same direction, but this is sending in opposite direction. So it is plus 10 minus 10 upon 5. 3 plus 2, 5. Similarly, what is the current in this? It is VA upon 2. Similarly, what is the current in here? The difference between the 2 junction voltages, VA minus VB upon the resistance, that is 8, is equals to 0. Once I resolve it, I will be having the equations 33 VA minus 5 VB is equals to 0. Okay. Now, applying KCL at junction B. So, the equation we are writing it as, the second is VA upon 2, right? And the third, that will be VA minus VB upon 8 is equals to 0. Resolving it into VA and VB, the equation what will be getting is 33 VA minus 5 VB is equals to 0. Similarly, applying KCL at junction B, right, we will be getting For this branch, we'll be getting it as VB minus VA upon the resistance is 8 plus VB upon 3 for this branch. And for this, if at all you see, this is VB. This is also sending the current in the same direction. So I need to write it as VB plus 25 upon 5 is equals to 0. If this is so, resolving it, I'll be having the another equation, that is 15 VA minus 79 VB is equals to 600. Two equations, two unknowns, solving for them, I'll be having VA as minus 1.18 volts and VB as minus 7.82 volts. If that is so, the question is find the current in 8 ohms, right? So the current in 8 ohms is going to be the difference of the two voltages divided by the resistance. The difference of the two voltages, the one which is greater. So I may consider minus 7.82 minus of minus 1.18 upon 8, it is going to be minus 0.83 amperes. So the current in 8 ohms is 0.83 amperes from, we are considering B to A, I am considering B to be greater once I write minus 7.82, but it is minus, it means it will be travelling from A to B in the opposite direction. The last one, using nodal analysis, find the current through 4 ohms, right? Once, in this case, this is most simple one, in this I am having a single junction here, right? A single junction, another one is also there which is considering to be at 0 potential. Say this is VA, applying KCL at VA, at junction A. Once again, 3 branches, 1, 2 and 3. How can I write the equation? This is going to be VA minus 2 upon 2 plus 4, that is 6, plus VA upon 8. This is the current which is in opposite direction, not in this direction. This is 2 ampere directly. So minus 2 is equals to 0. If that is so, VA is going to be 8 volts. Single equation that can be solved easily. If VA is 4, what is going to be the current in 4 ohms? It is going to be, this we got it as 8 volts. So 8 minus 2 upon 6. So that is going to be 6 upon 6, 1 amperes. So if the current is 1 ampere, what is the voltage across 4 ohms? The voltage across 4 ohms is going to be 1 into 4, that is 4 volts, right? The reference is what I have taken for the presentation, that is the books D.P. Kothari and I.J. Nagrath, Kulshresht also. Thank you all for listening this patiently. Thank you.